Okay, I want to begin our next video. Our next video will come from section 5.5, part 1. And this video is on factoring, or more specifically, factoring polynomials. Now, before I begin this chapter, and I always do this at the beginning of this section every time I teach it each semester, and I'm not going to labor long here on this thought or what I want to say, but I do want to say this. Of all the sections that we teach, of all the topics that I have taught, you have looked at up until now, I mean, all of them are important. You use solving linear equations and multiplying polynomials and rules of exponents and adding and subtracting. All of those topics are important. But if I had to just single out, if I had a student that was in going into my college algebra class right now, and they called me and said, Mr. Rayner, I just finished your intermediate class, and I'm just going to review back over a few things before I start my college algebra class. If they was to ask me to give 3 or 4 topics that if they needed to go back and review before they went into college algebra, probably the first topic that I would say that you better really make sure you got this nailed down is this topic that we're about to start now, called factoring, or factoring polynomials. It is very, very, very important, not only because of how it affects the rest of this course, but it also affects your college algebra. And so, there are some topics that we cover in here that, if you don't get a super good grip on it, won't necessarily come back to bite you. There's sometimes we find things more difficult, or maybe we didn't learn it as well as we should have. For instance, we just finished synthetic division. Now, you're going to have a test you'll have a test that will have a synthetic division problem on it. But as far as in the grand scheme of things, synthetic division is not going to make or break you in your algebra courses. This is one that has a devastating effect because it is used so much, particularly when we get into college algebra. One of the most common asked questions students when they get in our college algebra class, when they come to our office, is one of the most common questions frequently asked that they've forgotten or didn't learn how to do was this concept right here called factoring. So this is a very, very, very important concept. Now, this will take, we're going to be doing factoring in section 5.5, 5.6. There's like 3 sections in 5.6, and then 5.7. So your next, probably, if I just had to guess, 10 to 12 videos is all going to be surrounded around this one topic called factoring polynomials. Now, before we ease off into this topic, let's first of all make sure that you know what we mean when we say factor a polynomial. So let's talk about first, what do I mean when I say factor a number? If I said factor, give me one way to factor 12. That means give me a way to write 12 as a product of 2 or more numbers. For instance, if I said factor 12 and you said 3 times 4, that's factoring. What you do is you take what you begin with, and when you factor it, you're rewriting it as a multiplication problem. So when I say factor something, I mean give me what times what will give you that. Now, of course, if you factor 12, there's more ways to factor 12 other than 3 times 4. You could factor 12 as 2 times 6. Or you could factor it into 3 numbers. You could say 12 is 2 times 2 times 3. So when you're factoring something, it may be the product of 3 things. It may not just be the product of 2 things. And then, of course, the most obvious is 1 times 12. So what we're going to look at in this chapter is we're going to be talking about factoring polynomials. Now, in this course, we're going to learn how to factor polynomials of 3 different types. We're going to learn how to factor binomials, which is 2 terms, trinomials, which is 3 terms, and then we're going to factor some polynomials that have 4 terms in it. So all of our factoring problems, when I say factor the polynomial, it will have at least 2 terms. It will have no more than 4 terms. So 2, 3, or 4 terms. Now, what do I mean when I say factor the polynomial? I mean, give me 2 things that multiply together to give you that. Let me just get a little ahead of myself and show you an example. So if I ask you to factor this polynomial right here, x squared minus 2x minus 15. What I want to know is what times what else gives you that. That's what we're looking for when we factor. Now, never mind how you factor. I'm not ready to discuss that yet. But let me just show you. If you multiply these 2 things together and you get this, then this is the factored form of this. For instance, if I multiply this by the FOIL method, this is x squared plus 3x minus 5x minus 15, which is x squared minus 2x minus 15. So that checks out. So when we factor this, this is how it factors. So that's the answer to this problem. So if I say factor this, there's your answer. So that's what factoring is. You're looking for what 2 things or what 3 things multiplies together to give you that. Now, if I ask you to factor, let's start back over. If I ask you to find 2 things that multiply together to give you this, it is always a given fact if you do 1 times this. That is one way to factor that. So if I factor this, this is one way. Obviously, I don't want that way, because if that were the case, then that would be the answer to every one of the problems. So when we say factor a polynomial, I want you to give me a way to factor it other than the obvious 1 times 12, and 1 times this. So we're looking for some other way. So see, really, x squared minus 2x minus 15, it really factors 2 ways. The obvious one, but also this one. Now, some polynomials will only factor as 1 times itself. For instance, if I said factor 12, are there multiple ways to factor it? Yes. If I said factor 21, are there multiple ways to factor 21? Yes. But if I said factor 11, how many ways will 11 factor? Only 1. 1 times 11. If I ask you to factor 19, it only factors 1 way. 1 times 19. Now, what do we call numbers 13 and 19 that only factor as 1 times itself? We call those numbers prime. Well, it's the same way with polynomials. It turns out that there are some polynomials that will only factor 1 way, and that's 1 times itself. For instance, and again, I don't expect you to know why right now, but this problem right here, this problem does not factor any way other than this. 1 times itself. It won't factor any other way. So this problem right here, we would call this trinomial prime. Now again, I'll show you why later on why it doesn't factor any other way. But that's what we call this trinomial. We say that it's prime. Another word we use sometimes is the word non-factorable. So if a polynomial does not factor other than 1 times itself, it's prime. All right, Now, still haven't talked about how to factor yet, and it's going to take a lot of videos for us to get all the way through this. But I want to chase one other rabbit before we get started, and it's this. If I ask you to give me the factors of, say, 12, 1, 2, 3, 4, 6, and 12. Those are all of the factors of 12. So when I say, what are the factors of something, I just want to know, give me everything that divides evenly into 12. Now, if I ask you to give me the factors of 11, it's 1 and 11. So then, wouldn't it be true that everything has at least how many factors? At least 2. What are they? 1 and itself. 1 and itself. Now, it may have other factors, but everything has at least 2 factors. 1 in itself. Now, let's convert this over now into algebra. If I ask you to give me all of the factors of x to the third, well, we just said that everything has how many factors? 2. What are they? 1 and itself. But it turns out that there's actually a couple of other things that divides into x to the third. Let me show you what they are. X to the first and x to the second also. Now, let me show you why. Remember, we said it's a factor if it divides evenly into it. So will x divide into x to the third? Yes. Leaves x squared. Will x to the second divide into x to the third? Yes. It leaves x. Now, will x to the fourth divide? Excuse me. Will x to the fourth divide into x to the third? No. It will, but it leaves an x in the bottom, so it doesn't completely divide out. So x to the fourth is too big. So, listen to what divides into x to the third. 1, of course 1 divides into anything, and then x to the first, x to the second, x to the third. Every one of those divide into x to the third. So if you use that pattern, then if I say, give me everything that divides into m to the fifth, it would be 1, because 1 divides into anything, then m to the first, m to the second, m to the third, m to the fourth, and m to the fifth. Every one of those divides into m to the fifth. All right, now I'm headed somewhere with this, so just stay with me a few more minutes. So if I said, give me all of the factors of 12x to the fourth. What would be all of the factors of 12x to the fourth? What we do is we do the numbers separately. 1, 2, 3, 4, 6, and 12. Those are all the numbers that divide into 12. Now, everything that divides into x to the fourth. 1, I've already got it. X to the first, x to the second, x to the third, x to the fourth. So that is everything that divides evenly into x to the fourth. Or a combination of any one of these numbers with any one of these letters would also divide into 12x to the fourth. All right. So, let's continue now. Okay, so I'm about to give you your first huge note on factoring. Make sure you write every word of this down. All right, before I give you the note, remember, every polynomial we factor will either have 2 terms, 3 terms, or 4 terms in it. Okay, So, what do we do first when we try to factor a problem? What do we try first? All right, here's the note. Take this note down. Pause the video as you need to. The first step in factoring any polynomial is to see if there is a greatest common factor, and then in parentheses beside that write GCF, to see if there is a greatest common factor, or GCF, other than one that will divide evenly into every term of the polynomial being factored. Okay, so the first step in factoring is to see if there is a greatest common factor, other than one, that will divide evenly into every one of the terms of the polynomial being factored. So in other words, here's what this means. If I've got two terms, what I'm doing is finding the biggest, it's called greatest, factor, that's why it's called greatest factor, that divides into both of those. Common, greatest common factor. So we call this looking for the GCF. Starting right now, every problem that I do with you over the next 8 to 10 videos, every problem that we do, I will begin by looking for this. Now, we're going to eventually get to where we do other things, but we will always do this first in every single problem over the next 12 videos. I'll say, okay, let's check for a GCF. What does that mean? See if there's something that divides into every one of the terms in that polynomial. And if it is, then that's your GCF. Now, once again, if there is nothing that divides into every term, one does. So in that case, we would say that it's prime or non-factorable at this stage of the game. All right, so we're ready to begin our problems. So we're about to look at factor the following problems by using the GCF. And I think, let me check my time. I think I'll go ahead and this is a good place to stop right here. I will stop right here and we will begin our part 2 video with our actual examples.